Yancey. I have served as the chair of the Composites Factory of the Future 4.0 Technical Committee, and this will be a summary of the State of the Industry report that we published earlier this year, and this is the summary presentation given at the SAMPE Seattle conference in the spring of 2023. In terms of the scope of our committee, we are focused on the evolution of technology to drive increased efficiency in manufacturing. It is focused both on the manufacturing composite materials and composite structures. It encompasses the full extent of automation, data acquisition, analytics, and artificial intelligence technologies to drive increased efficiency, decrease downtime, operational insights, reduce scrap, and preventative maintenance signals. The Composites Factory of the Future subcommittee seeks to explore how these new technologies apply to and impact composite materials and parts-related processes to drive disruptive and radical outcomes in quality, throughput, cost, potential new applications, and advanced business models. The organization of our committee is as follows. I'm the chair. Muthu of Pacific Northwest Lab is the vice chair. Matt Thorne of Majestic Technologies was secretary. And then we decided to divide up the work into four subtasks. One on equipment led by Phil Viviano of Whisk-Arrow, software led by Michael Spellman of Majestic Technologies, materials led by Kevin Simmons of Pacific Northwest Lab, and processes led by Cameron Hogue of Rebuild Manufacturing. For the report, we ended up combining the equipment and processes sections since there was a fair amount of overlap in what was prepared. So I'll cover a summary of those three sections in our published report. First of all, on equipment and processing, we looked at a number of current tools that are listed here, and then we identified the needs in the future. There is a need for lower cost and more easily programmable equipment. Many of these pieces of automated equipment are multi-million dollars and can take significant time and expertise in order to be able to program. So basically reducing the cost of that equipment and making it easier for less experienced people to be able to program it. There is a need for more automated inline inspection so that we can get more data during the manufacturing process of what's going on. And then adaptable equipment that can actually correct defects before they become an issue. So if you have a sensor that detects something, you might have corrective action that can be automatically deployed without operator intervention. This subcommittee subtask was led by Phil Viviano, and you can see the other participants listed here. On software, we reviewed both software used kind of during the design and analysis of the structure. So CAD/CAM and FEA tool, along with Cure modeling tools. Then there's software for basically driving the equipment and programming the equipment, path planning, NC programming, and then data software to be able to take sensor data and to perform data analytics on that. In terms of the needs identified, there continues to be a need for more specific composite tools in the standard CAD/CAM and FEA tools that are commonly used in industry. We need easier to use manufacturing equipment programming that's better integrated with CAD so that once the design is completed, the programming can be more automated. And then better use of the sensor data to improve quality and reduce scrap. Michael Spellman chaired this subtask, and you can see the other participants listed here. And then for materials, we reviewed epoxy resin systems, vinyl ester systems, polyester resin systems, and thermoplastics. In terms of the needs, there's a lot of need in the industry for more sustainable materials, and so we have natural fiber and resin systems, and also materials that are more amenable to recycling and reuse. Also, there's a need for more polymer fiber systems to combine with glass or carbon fibers to improve performance. Many times they're added to improve toughness or impact resistance. And then there is a need for ultra-thin composite prepregs. These add a lot of mechanical property improvements, but they're typically more expensive to manufacture and to process. So ways to be able to drive down those costs so that we can achieve the mechanical property improvements with them without significantly impacting the mechanical properties. So this is a summary of the report. There's over 40 pages of content in the State of the Industry report. I encourage you to download that report and review that in detail. And these are as along with the reports from the other technical committees, and these will continue to be updated. Thank you.